Okay, good afternoon, class. Today we're gonna discuss section 1.4. In section 1.4, good class, we have the different types of functions. Okay, all right. So let me get an eraser before I keep going. Let me get an eraser. Okay, give me a second. Okay, so here's my eraser, a napkin. All right, so we're going to discuss section 1.4, which is different types of functions. Now, the first type of function is what we call a constant function. And what is a constant function? Okay. Let me give you an example of a constant function. This is section 1.4. A constant function is f of x equals b, where b is a number. Okay? That's a constant function. B is a number, a constant. So this, we call this a constant function. Okay? All right, so here's a constant function. I just replace this b with a number. For example, f of x equals 2. b is 2. Okay? And so therefore, we can graph this constant function. Yes, we can. And so therefore, we go to the x-axis and the y-axis, and we graph f of x equals 2. Note, if you want to give a table, here's x, and here is f of x. So when x is 0, guess what f of x is? 2. If x is 1, what is f of x? 2. If x is 2, what is f of x? 2. If x is negative 1, what's f of x? 2. That's what we call a constant. F of x is always 2. If x is negative 1,000, what's f of x? 2. Okay. Let's graph it. X equals 0, y is 2. X equals 0, y is 1 and 2 right there. X equals 1, y is 2. X equals 2, f of 2 is 2. X equals negative 1, 2. Negative 2, 2, it's always 2. What if x equals to a half? Yeah, half. What if x equals to 1/2? What is f of x? 2. Half. This is 1, this is 2. If x is half, what is it? 2. It's always 2. So that's where you get this line. Okay, you get this line. It's a straight line. And I don't care what anybody thinks, that's a straight line. Constant functions. Okay? From constant functions, we can jump into linear functions. Yep. Linear functions. From constant functions, now we're going to go into linear functions. Okay? And what is a linear function? Well, a linear function is the following. Okay? A linear function, good class, a linear function is this. So that's a constant function. Now we're going to go into, by the way, that's a linear function also, okay? This is also a linear function. Okay? Here, I'll write the linear function right on this side. Linear function. is f of x equals mx plus b. That's a linear function. Note, m stands for the slope, and b is a constant. It's a number. We call b the y-intercept. So m is the slope, and b is the y-intercept. All right. And so therefore, what's an example of a linear function? Here's an example. Example. F of x equals to 3 over 2x plus 4. Okay? That's an example right there of a linear function. Okay? Look at the slope. The slope equals to 3 over 2. Now remember, good class, remember that the slope is the rise over the run. So the slope here is the rise over the run. Okay? And look at b. b equals to 4. b really is the y value of the point where the line crosses the y-axis. That's what we call it, the y-intercept. Okay. Let me graph this one, good class. All right, let me graph this one. So here we go. I'm graphing this one right now. Okay. So here is the x-axis, and here is the y-axis. Okay. And note, the rise is 3, the run is 2, the y-intercept is 4. So go to 4 on the y-axis. Here is the y-axis. By the way, this y is f of x. This is f of x, okay? We know it as y, but you may call it f of x. In fact, I don't have to write y anymore. I can just write f of x. So this is f of x. Yep, right there. Okay. And so now I'm going to go to the y-intercept, which is 4. So 1, 2, 3, and 4 right there. Okay. And then I'm going to rise 3 from the y-intercept. I'm going to rise 3, and I'm going to run 2. From this y-intercept, I'm going to rise 1, 2, and 3, and I'm going to run 1 and 2. So rise 3, run 2 right there. And that's a point on this function. This point, by the way, can you find this point? Can you find this point? This point makes this function true. Okay? Watch this. What are the coordinates of this point? I see x equals 2. And I see y is what? 1, 2, 3, 4, 5, 6, 7. Y is 7. I bet you here, if you plug in x equals 2, you're going to get f of 2 equals 7. Why? Because this point is a point for this function. Watch. If you don't believe me, watch this. X equals 2. I'm going to plug in 2 into this function, which is what? 3 over 2 times 2 plus 4. The 2's cancel, and we get 3 plus 4, which equals to 7. You see that? 2 and 7. So, graphing this way works. Why? Because we went to the y-intercept, then we rose 3, 1, 2, 3, and we ran 2, and we found a point that belongs to this function. And now you just connect the points with a straight line. So here is a straight line, and I don't care what anybody thinks. That's a straight line this way. And so we call this a linear function. By the way, this also satisfies the definition of a linear function. Except, you know what this is missing? You know what's missing for this one? It's missing the mx. That's what is missing. In reality, the slope is 0. The slope is 0 here. Here we have 0x plus 2. Okay? So note, when f of x equals to a number, that's a horizontal line. Can you guys guess what the slope is on a horizontal line? Think about it this way. If you walk on this floor, okay, what is the slope of this floor? Because this floor is really horizontal. This wall is vertical, but the floor is horizontal. Can someone tell me what the slope of this floor is? The slope is 0. Hey, this has slope of 0. Watch this. This one here has slope of 0 because I'm going to do it in red. This one here. Here is the graph. Horizontal. Horizontal. The slope is 0 here. Slope of 0. So constant functions have 0 slope. Whereas this function right here does not have 0 slope because look, it's increasing. This function is increasing. And look at the slope. The slope is positive. So increasing functions have positive slope. Decreasing functions have negative slope. And we're talking about linear functions. Okay? So therefore, this function, look right here, this one has a slope of rise 3, run 2. That's the slope. The slope from this point, you can always, by the way, you can always find the slope if you have 2 points on the line. You can always find the slope. Here I have 2 points. So look, I rise 3 and I run 2. And so the slope is 3 over 2. The slope for this graph. Okay, very good. Here is, okay, so this is a constant function, and this one is also a linear function, okay, with a slope of 3 over 2. This is also considered a linear function, okay, because here the slope is 0, okay? It's 0 times x plus 2. All right, very good, good class, very good. Let me give you another linear function, and we're going to give you 2 points for this linear function. We're going to rise and we're going to run from those 2 points, and we have the slope of that line. Watch this. So I got to erase this now, okay? This, by the way, positive slope, increasing. Negative slope, decreasing. Don't forget that. All right, so here we go. Let's erase this. Here we go. Watch this. So here's a function. Here's a function. But I'm going to give it the slope. I'm going to give the slope. Okay. So how should I do this? How should I do this? The slope of this function, the slope is negative 2/3. Yep. It's a linear function, okay? I'm letting you know right now, it's a linear function. And a point on this function, let me give you a point. A point on this function is, I'm gonna say 4, 3. Okay, here you go. We have the slope and we have a point. And so now, all we have to do, watch this. Here's x. Here's f of x. That's what we're looking for. The point is 1, 2, 3, 4, and 3. 1, 2, and 3. And there you go. You see? And I can graph it now. I can graph it. I'm looking for f of x. Let's call it g of x. What is g of x? Okay. I can graph it because I go to the point 4, 3. And look, I'm going to rise and I'm going to run. You see this negative? You have two choices. You either bring it up or you bring it down. Okay? So therefore, I'm going to, let me see, I'm going to bring it up. -2/3. And so now, good class, the rise is -2 and the run is 3. So from this point, I'm gonna rise. By the way, I'm not giving you, look, this point here is not the y-intercept. That's not the y-intercept, okay? I didn't give you B. I did not give you B. The rise or the run. But we can still graph it with this information. And so go to the point 4, 3 and rise -2. So rise down 1 and 2 right there. Rise 2 down and run 3 to the right. 1, 2, and 3 right there. And so we have the graph. Now this point belongs to this function that we don't know, and this point belongs to this function that we don't know. We don't know it, but we can still graph it. And so we get this. Okay? All right. The point is, the slope is important. The slope is very important. Okay? Now, hopefully tomorrow, I'm going to show you how to find the equation of this function. Not today because it's not today's topic. Okay? Tomorrow I will. Right now we're just looking at different functions. Here, I want you to graph the following. I want you to graph this one, look. Okay, so we have the graph for this one, okay? Tomorrow we'll discuss this one. Mañana. This was mañana. Mañana, guys, mañana. That means what? Tomorrow. Tomorrow I'll discuss this one. How to find the equation of the line of this function that passes to this point with this slope. Okay? Beautiful. Tomorrow. Okay? All right. I'm going to erase it now because I'm going to give you to graph another function. Okay? And I'm going to show you how to find the slope too. Okay? I'm going to show you how to find the slope of a line. Okay? All right. So here we go. Erase. Mañana. So here we go. Everybody. So h of x equals to, watch this, negative 5/2 x minus 2. Look, you can graph this. Go to the x-axis and go to h of x, which really is y-axis. Go to -2, and by the way, you need to do something with this negative. You can bring it down or up, not both. So go to -2, -1, -2, and that's the y-intercept. Okay? And now this is the right, so the slope is, you gotta do something with that negative. You have two choices. You can bring it up or down. I'm gonna bring it down. So according to the way I have it, from here I'm gonna rise 5, positive 5, so you go up. So rise 5, 1, 2, 3, 4, and 5, and run 2 left. 1 and 2 left, so rise 5 up and 2 left, and this one here is another point in this function. Yep, it's another point. And so we connect the 2 points, good class, and there we go, and there we go. Okay? Note, you can give me the coordinates of this point. What are the coordinates? The coordinates are x is -2, y is 3. If you plug in x equals -2 there, you're gonna get h of -2 is 3. Okay? Can someone give me the coordinates of this point? Can you give me the coordinates of this point? Sure you can. This is x is what? X equals to 0. And what is y? -2. Okay? Watch this. From this point, the rise is 5 and the run is 2 to the left, -2. You see this point and this point? We can use those 2 points to find the slope. Sure we can. So the slope is y2 minus y1 over x2 minus x1. Use this formula to find the slope. You can use that formula. Okay. So here we have 2 points, x1, y1, x2, y2, to find the slope. Okay. So you have to label one of these, the first point, and the other one the second point. It doesn't matter which one, guys. Let me ask you, which one you want to label? Which one do you want to label the first point? You want to label this one the first point? Okay. I'm going to label this one the second point. Why? It doesn't really matter. That's my point. Watch this. I'm going to call this the second point. This must be the first point. There you go. Okay. If this is the second point, this must be x2, y2. And because this is the first point, this must be x1, y1. And so now I'm going to use that formula to find the slope of this. We already know it, by the way. We already know it. It's right there. I'm just confirming. I'm showing you, or I am reminding you how to find the slope by using this formula. Okay? So that's y2 and that's y1. y2 is -2. So this equals to y2, which is -2, minus y1. y1 is 3. Over x2 is 0. x2 is 0 minus x1. What is x1? x1 is -2. And look, what is the top? The top is -5. And what is the bottom? The bottom is +2. And what's a negative divided by negative? I'm sorry, negative divided by positive. -5 over 2. Same thing as this one. Okay. So that's how we find the slope. Okay. Now, some functions curve. Okay. Some functions do have a curve. All right. Let me give you an example of functions that are not linear. Okay. So let me erase this now. I'm going to erase this. So watch this, good class, watch this. I'm gonna graph for you guys, okay? I'm gonna graph this function. It's a function. I'm gonna show you that it is a function because I'm gonna make sure that it passes the vertical line test. Okay? I'm not gonna give you the actual function, I'm just gonna graph it. I'm gonna give you the graph of a function. So here we go. I'm going to call this f of x. So watch this function, okay? I have to make sure that it passes the vertical line test. Okay, no problem. So I'll do this. I'm going to say this is 1, -1, -2. This is 1 and 2. 1, 2, and 3. So I'm just going to do this, good class. I'm just going to do this, okay? Here I'm going to go there. And here I'm going to go there. And here I am going to go there. And here I'm gonna say this is -1. And so I'm gonna do this. And then I'm gonna do this. Okay? You understand? This is definitely a function. Okay? Look, class. here's what we want for this function. What we want for this function is, where is the function increasing? And when we say where, we want the x values. Okay, the x values where the function is increasing, and the x values where the function is increasing and decreasing, I'm sorry. And so when we say x values, we want the intervals. Okay? So if you were walking on this function, we want to know where this function is increasing and where this function is decreasing. So you have to consider every interval where the function is increasing. Okay? So for example, go here. Okay, go to this part of the function and step on it. You're always looking that way. Always look that way. Okay? This is your hat. This is you. You're looking that way. Okay? That's your mouth. Okay? Always look that way. Towards positive infinity. And then determine where the function is increasing, and we want those x values where this function is increasing. So if you're always looking towards that way and you're always walking towards that way, okay, it seems to me that here the function is increasing. Okay, so you're walking this way. And by the way, look at here. This is you. And look, if you go up, we want this x value. We don't have it exactly, but at least we know that this is negative. This x value is negative. Okay? So you continue walking this way, and you get to this point. You're looking that way. Okay? You're walking that way. Look here, the function is increasing still because you're still walking up. And you want this, what is it that you want? You want this x value. This x value is negative. Okay, so you walk and you get to the tip right here. This tip, that's you right there. You're standing on the tip now. Well, here, you're standing there. Okay, and so you got to this maximum value. And now, you're still walking that way. Okay, so what is this x value? This x value is -1. This x value here is 1. This x value here is 2. This x value here is 0. This y value here is -1. But we don't care about the y values. We want the x values for now. So here, so it seems to me that this function is increasing. F of x increases. So far, from negative infinity, because this goes forever and ever, from negative infinity up to what? Up to -1. It increases right there, okay, and it gets to the tip here, the maximum, okay, and now it's going to begin to decrease. So where does the function decreases? F of x decreases. We want the x values, don't forget. Here at -1, you're on the tip right there. and now you begin to decrease. You see that? That's -½ That's x equals 0. That's x equals 1 right there. And this is where you begin to decrease right there, right? Right there in the middle. I'm going to say that's the middle, okay? And what is that value? 1.5. Yep. Decreases. Where? From -1 all the way up to what? 1.5 right there. So you get to this point right there, and this here is the minimum. Okay? So it decreases from -1 all the way up to not negative, 3/2. These are intervals. It's an interval. From -1 up to 3/2, this is 1.5. Decreases. And then look what happens. Now you begin to increase. You begin, look, if you start walking this way, now you're increasing again. So therefore, f of x increases where? We better write or. Or where? From this x value, which is what? 1.5 all the way up to what? Infinity. So this function increases from -infinity there, and from up to this point, up to this x value, up to -1, it increases from 1.5 up to infinity. And it decreases from -1 up to 1.5. Okay. All right. Excelente. Now, let me give you a function that's an actual function right now. I'm going to give you an actual function. This one, look. Actual function. I'm going to make it this one. Oh, by the way, one more thing. You see this point here? That's where the function is 0. This value right there, that's where the function is 0. So this is an x, this x value is where the function is 0. So we're gonna call this the 0 of the function. We'll talk about that more. There's another 0. In other words, the zeros are the x-intercepts. And that's another 0 right there. So that's a 0, that's an x-intercept. An x-intercept, but in this book, we call them zeros. So x-intercepts are called zeros. So that's a 0, and that's a 0, and that's a 0 for those x values. For the x values, okay? All right, very good. So, watch this. Consider the following, good class. Consider the following, okay? Here, I'll give you this one. G of x equals to x squared plus 2. That's a function. It's a function. Okay. Let's graph it. Graphing this function. Okay? You can make a table. X and g of x. When x is 0, g of x, what's g of 0? 2. Okay, when x is 1, what's 1 squared? 1 plus 2, 3. When x is 2, what's 2 squared? 4. Plus 2, 6. Okay. When x is negative 1, what's negative 1 squared? 1. Plus 2, 3. When x is negative 2, what's negative 2 squared? 4. Plus 2, 6. Okay. All right. So don't forget, we're going to ask here, we're going to ask where is the function increasing. We want the x intervals where the function is increasing or decreasing. Okay, so got to get rid of this one because I'm going to graph that. So here we go. Now, let's graph it. Okay. All right, so here we go. When x is 0, we get 2. X is 0, we get 2. See it? Right there. When x is 1, we get 3. X is negative 1, we get 3. X is 2, we get 6. 3, 4, 5, 6. X is negative 3, negative 2, we get 6. And so we're getting this. There we go. Okay, can you tell me where the function is increasing and decreasing? You see here? Remember, you're always walking in that direction. You see here? If you walk this way, it's decreasing. And then you begin to increase. Can you give me the interval where this function is increasing and decreasing? Okay. G of x. Increasing. Where? Well, increasing right there. You're walking that way. Always walk that way, okay? Increasing right there. But we want the x values. The x values. It increases from 0 up to infinity. Okay? G of x decreasing. Where is it decreasing? Decreasing right here. You're walking, you're on the function, okay? You're on the function right there. You're on the function. You're walking on the function that way, and you're decreasing right there. But we want the x values. So it decreases all the way up to x equals 0. So decreasing from negative infinity all the way up to 0. Right there. Now, watch this. Here's one thing that this book is going to ask, and it is the following. They call this the difference quotient. Okay? They call this the difference quotient. Okay, we're almost done. You see, take 2 points. Take 2 points. Any 2 points. Watch this. I'll take this point. And I call this point X. And I'll take another point right there. And this point, the distance from this X value to this other one is H. This distance is H. So if this is X, this must be what? The distance from here to there, okay? The distance from this X value to this other X value, the distance is H. H. So if this is X, what is this? This must be what? X plus H. Yeah. If this is X, this must be X plus H. And by the way, you see this point. This point, can you give me the coordinates? Sure you can. This point right there is going to be what? This point, I need room. This point right there is going to be X and what? And f of X. Do you see it? Yeah. What about this point? What are the coordinates of this point? This point is going to be X plus H. And what else? F of X plus H. Now, here, can we find the slope between these 2 points? Remember the slope formula? Let's find the slope between this point and that point. It's a line. Think of a line passing through those 2 points, okay? Think of a line that passes through these 2 points. It's a line that passes through them. A line passes through those 2 points. And we want the slope of that line. We want the slope of this red line. Okay? Remember how to find the slope? Do you remember? Show you. To find the slope, we use this formula. The slope is y2 minus y1 over x2 minus x1. And remember that we have to label them. Remember that? So let me call this the second point. And let me call this the first point. Which is right there. That's the first point. Because this second point, this must be x2, y2, just like before. Okay? And what is this? This must be x1, y1. Remember that? Okay, watch what's going to happen. You see, I'm going to find the slope between the slope of this red line between this point and that point. The slope. Okay, y2. What's y2? Right there. There! That's y2 right there. Yes. That's y2. Do you see it? This y2 is right there. F of x plus h minus y1. y1. There! Right there, f of x. Divided by x2. What's x2? There! X plus h. Minus. What's x1? x1. There! Anybody knows what this x minus that x is? 0. This x cancels that x. So this is f of x plus h minus f of x divided by what? H. They call this the difference quotient. Guys, the difference quotient is just the slope between 2 points. That's what it is. By the way, I use F, but I should use G. Because you see this graph? This graph is G. I should use G, but this is just a general formula, okay? This is just a general formula. They call this the difference quotient. Difference. 2 F's, right? I think so. Yes. Quotient. Okay. Now, because this, we're talking about this graph, and it is 2 points on this graph. 2 points on this graph. It means that this graph is G. So in reality, it should be G. So the difference quotient for our problem, it should be G of x plus h minus G of x divided by h. That's our problem. This is general. This is for any function. But for our problem, G. Wait a minute, guys. What will G do to this x plus h? There's G. G is going to take x plus h and square it. Do you see it? So this G, and then it's going to add 2. Look. So let me give you this much. What will G do to x plus h? Let me put it like this. What will G do to you if you went into G? If you were right there, what will G do to you? G will take you and square you and then add 2. That's what G would do to you. Okay? Watch this. What will G do to you? G would take you and square you and add 2. Whoever you are. Okay? Seeing that, what will G do to this? G will take this and square it and add 2. G would take this, x plus h, square it, and then what else? Add 2. According to this, look. That's this part. Minus g of x. What is g of x? Right there. Minus. What's g of x? X squared plus 2. Divided by what? Divided by h. Okay. Note, good class. This is there, and this is x squared plus 2. And it's subtraction. Okay. Now, does anybody remember how to square this. X plus h. Isn't that x plus h times x plus h, good class? How do you square this? X plus h squared is x plus h times x plus h, and then we have to FOIL. X times x is x squared, x times h is xh, h times x is xh, h times h is h squared. That's what this is. So this is all of this. Let's add this together. X squared plus what? Plus 2xh plus h squared. That's what that is. Plus that 2. Let's do it. I'm running out of room, okay? So this one right there, this one right here is all of that. It is x squared plus 2xh plus h squared. And now I did this plus 2 minus x squared minus 2 all over h. Okay? Very good. This 2 cancels this one. This h squared cancels that one. What is it that we get? What is it that we get? Good class. This is fun. This is fun. What is it that we get? This is gone, and this one is gone. This one is gone, that one is gone. We just get that one and that one. We get 2xh plus h squared divided by h. That's what we get. By the way, that's a power of 2, okay? Right there. Can we simplify this? Yes, we can. Yes, we can. How do we simplify this? Let's factor out an h. h times 2x plus h divided by h. Look, h times that is 2xh. h times h is h squared. Okay, but we needed to do that. And this h cancels this h. And yes, we got the difference quotient. What is the difference quotient? If you were to tell someone, if someone came to you and asked, hey, what is a difference quotient? What's the easiest thing to say? A slope. A slope. We just found a slope between this point and this point on this graph. Now, if the function changes, well then, all of this is going to change. Because this is for a specific function. Okay? So, in reality, what is the difference quotient for this one? I gotta erase this, okay? The difference quotient is right there. Okay? Okay, so how can I say this? Let me go here. This is the difference quotient for this function. Okay, good class, don't forget that. For this function, the difference quotient, f of x plus h minus f of x all over h. I should use g. Let me use g instead because, okay, this is general, but okay, if you want to use g, you can. For this function g is what? What is it? Right there. 2x plus h. Yay. Guess what? The slope of the line that passes through these 2 points, right there, this point and that point, for this graph is 2x plus h. All right, good class. All right, so that hopefully that's gonna get you going. Thank you very much, okay? And this is section 1.4. Have a nice day. Tomorrow I'm gonna do section 2.1 and 2.2, okay? Nachos gracias, good class. That means thank you very much, okay? Bye.